Okay, guys. So a very good afternoon to all of you. Today, in the yesterday class, basically, we started the chemical machining operations. We discussed about that. So, what is chemical? I'm just briefing. Okay, so that next we can start to the next process. So, chemical machining is the process like in which we are using the chemical composition chemicals. Okay, like agents we can say, and we are depositing the material. If I simply say define, then we are in a container. Basically, we are filling the chemical. We are calling it as a agent, and then we are dipping the workpiece that from which the area we have to remove. So workpiece basically, which is the workpiece, which is basically the cross sectional area from which from where basically we have to remove the material. We will keep it inside the container. Otherwise, the area from which basically we have to prevent the material, means we do not have to remove the material. We will like just a minute. Okay, so the area basically from which we do not have to remove the material, we are lapping it by or wrapping it by the masking material. Okay, so that process we are calling it as a masking, or the mask that we are lapping over the workpiece surface, that is either maskants or mask we can say. Okay, so that we have discussed. Okay, and today we are going to discuss about the electrochemical machining operations. Okay, so this is, we also call it as a ECM. Fine. So today basically, yesterday that we discussed the chemical machining, so that is like a very small amount of the material we are removing from that. But today actually from ECM only we are starting the actual advanced manufacturing processes. Okay, or machining processes we can say. Okay, now like if we are talking about the actual machining processes, then the process, I want to say that what content or what the steps that we have to follow in these. So all these machining operations, first we discuss about the principal part. Okay, that what is the principle it is involved. Then we'll go to the working part. Okay, that what is the working of that. And after that we will discuss about the material removal rate. Okay, so as I told you that we are calling it as a non-conventional machining operations. So every machine, every processes has different mechanism to remove the material. So the material removal rate is also a very very important criteria in the advanced machining operations. Okay, so that we will discuss. And after that, if there is any numerical problems that has been asked previously, or that is available in any of the standard books, that we will discuss. Okay, by the way, ECM, EDM, USM, the abrasive jet machining operations, these are the operations in which the number of numerical problems is available, because the material removal rate that we are getting, that has the numerical formulas. Okay, so that we will discuss in detail. Okay, so let's start. Okay, so as I said, the principle we will discuss. So first, the electrochemical machining operations, that is based on the Faraday's law. Okay, and or we can say in other words, that is the electrolysis principle. So what is the principle is that two electrodes placed in an electrolyte, and potential difference is applied in between the cathode and the anode. Okay, now both are like cathode. We are defining tool by the cathode. Okay, means the positive side is connected with the tool, and the negative side is connected with the tool, and the positive side is connected with the workpiece. Okay, uh, if we are doing this basically, then the material will be depleted from the anode side and dissolved in the electrolysis and form the sludges. Now depleted means the material is removed from the workpiece area. Now here we are not using the conventional machining operation, so we cannot say that the material removal, but actually the meaning of depleted means the material, the ions through which the material is removed from the workpiece, as it is dissolved inside the electrolysis we can say. So that is basically removed. Okay, so that area material that is removed, here we are defining that by the depletion. Okay, so that depletion rate is important here. Okay, so the material is depleted bit from the anode part. Anode means what? The workpiece. Okay, the workpiece that is made up of the we are here making that as a workpiece. So the workpiece, the material is removed or the depleted from uh, uh, the workpiece area, and that get dissolved into the electrolysis and form the sludge. Sludge is nothing but the wastage material. Okay, so that wastage material is formed and that is sedimented over the workpiece surface. So as I said, this is the principle. So this principle is nothing but, if I simply say, then hope you are aware about that this is nothing but the EC cell. Okay, electrochemical cell. So what is the that why I'm saying like that, because I am aware that I am expecting that you have studied these things in the 11th or 12th. Okay, physics. Okay, so EC cell, that how the EC cell is formed, that there are two electrodes are there. So two electrodes we are dipping inside the electrolysis, and these two electrodes are connected with a potential difference. Now DC supply. Okay, the DC power supply. Okay, so potential difference is created, and the as the potential differences create the current flow, and that will releases the ions. Okay, and because of that the material is removed or depleted. So this is the concept. Now how this concept how the principle is work basically here is, for that this is the initial stage and this is the steady stage, means after some time. Okay, so at the initial stage we are considering the container. This is basically the container. Okay, and in which we are filling the electrolysis up to some specific length. Okay, means electrolysis we are filling, like it should be completed the EC cell. Okay, means the electrodes that we are taking of specific height, that will be completely dissolved into the electrolysis. Okay, so the up to a specific height we are filling the electrolysis in that, and this is the workpiece and this is the tool. Okay, now both are connected with the potential power supply. So here the potential difference, this is the power supply. Here the potential difference is created. Potential difference means the power supply is start, means we are basically initiating the power and sorry, voltage and the current. Okay, so power supply is start, and then the material start ionization is takes place. So how this takes place, that I'm going to discuss. Okay, so workpiece, this is the workpiece. Here the workpiece is connected with the anode. So this is the anode side. Okay, and this is the tool, which is a cathode side. Okay, now what is the concept that we are using here is, in the principle that uh, we need to maintain a minimum gap between the workpiece and the tool. For an example, if this is the workpiece, okay, this is the workpiece and this is the tool. Fine, so what we have to do is this curve shape, this is the curve shape is there. So this curve shape we have to make on this one. Okay, on this workpiece. So what we can do is like, means this surface we have to create, means we want that this workpiece should become concave means that this should become circular inside, not outside. Okay, it will not become like this, but it will go inside this. Okay, so this surface will become concave. So what we are taking is, we are taking convex shape. It means that the replica of that object, okay, means the replica of the workpiece that we are creating on the tool side. So please keep in mind, whatever the shape that you have to prepare on the workpiece side, just opposite to that or the replica of that, just make the tool as it is. Okay, so so this is the tool. Here it is, this is the tool we are taking. Okay, now if I simply say, then if I simply discuss the principal part, then okay, just assume that this was initially it is horizontal. Okay, so the minimum gap should be required. So minimum gap means, if it is completely cross section, means flayed throughout the length from here to here, then this minimum gap should be required between the workpiece and the tool. After that only is you will reduce this gap, the material in the resistance is increases, and because of the registration resistance, the material start depleting from the workpiece surface. Okay, so what is happening if so like, on behalf of taking plate, this shape, for an example, this type of shape. Okay, this type of shape we have to create over the workpiece surface on like this. Okay, like this we have to create. So the replica of that we have created over the tool side. Fine, now actually this is the initially the workpiece area. Okay, the workpiece cross section, which is near to the cross section of the tool. So what is happening is the potential difference is created, the ionize has been ionized, means ions get releases from the workpiece area. Then try to move this tool in this direction towards the left side or towards the workpiece, we can say is we will move this tool towards the workpiece side. this gap between this area and this gap is decreases. Initially this was like we can say this much. Now when you will move this tool toward this side, this gap is decreases. Okay, when this gap is decreases, the material start removing from the workpiece surface. Okay, so like if you will see, okay, like if you will see that as you are moving toward this side, then this area, this point, because this is the top point, means top point means we can say that is the nearest point, okay, to the workpiece from the tool side. So this tool, this point will come in contact initially with this cross section area, not come in contact, but the minimum gap will be there. So the material will start removing from this uh, whatever the cross sectional area that is coming in contact with that. Okay, so as we are regularly, means continuously pushing this tool, or we are moving this tool toward this side, this will remove the material like this, or deplete it the from the workpiece area. So now whatever the, now we can say, if this is the periphery, for example, this is the center and this is the radius. Okay, so semi sphere basically we have to make. So this semi sphere, now when this surface is become minimum gap between these, like this tool is come over here like this. Okay, now if this complete part is formed over here, okay, now if you will still moving this tool towards this workpiece side, now the material will start removing from this area, from this cross sectional area. Okay, because now this minimum gap should not be maintained, it is decreasing as we are moving this tool toward this side. So we have to keep in mind, once the job is completed, after that just move, keep away the tool from the workpiece area. Okay, now the material is removed. So everything is basically this is the initial stage. As I said, that potential difference is created after some times only, when the as it is a DC power supply, so it takes little bit time to get charged. So once this charging is takes place, after that the ion start depleting, start releasing from the positive side and the negative side, means from the workpiece and the tool or electrolysis. Then they will react with each other, and when they will react, then only the steady state will reaches. After that only this process will happen. Okay, so this process actually I have to tell here. Okay, so please try to understand, in initial stage you are just maintaining, you are just making the EC cell. After the potential difference is created, after some times it is reaching to the steady state condition. Okay, so this principle is clear, guys. So if you have any doubt, you can ask me here. Then we are moving towards the working side. Guys, are you there or sleeping?
Yes, sir. We
Yes,
don't
sir.
have any
Yes, sir.
problem.
Okay, okay,
समझ
great,
आ रहा है.
great. Okay, then let's start to the work, move to the working side. Okay, so now okay, now if you will go through a book, any of the book, like P N Rao, you can take. Okay, or like Kalpak Jain, you can take. So in both the books, like in one of the book, I think in Kalpak Jain, sorry, in one of the book, like you can just take, in one of the book it is mentioned that he is using just simple water like H2O he is using, and in another book they are using the salty water. Okay, so if we are taking, first of all, means how this reaction will be different, because salty water is taking, so salt is like NaCl, so NaCl will also, like when you will create the potential difference, the positive ions and the negative ion will be bifurcated, so they will also react with the H2O ions and H2O, and that will make the another sludges. So that's this is how the reaction, means what the reaction is takes place, that is important. Now, as I said, that if you will study one book, then in which water is mentioned is the main electrolysis, because electrolysis, electrolyte also we have to use, and water is like freely available, so we can use that very easily, and we can use the salty water to increase the reaction. Okay, to make the reaction very fast. So I am taking both the example. Okay, by the way, if I will ask in the paper, then I can ask both, or if I will not mention, you have to write the both, then any one of you, any one of these you can write. Okay, So like first is working. Okay, working part using the simple water. So this electrolysis is there. Okay, this is the electrolysis. Now this is nothing but the H2O. Okay, and there are some properties which is characteristics or the properties we can say which is very important here with the electrolysis. So that I will discuss after two to three slides. But right now just I'm briefing that here we are using H2O as the electrolysis, and iron, the workpiece here we are considering that is made up of the iron. Okay, now okay, so this is the anode side, this is the workpiece, that is the anode. So this is the positive side, and this is the cathode. So this is the negative side. Okay, now the potential difference is created. Okay, once the potential difference is created and the steady state is reaches, after that the ions start releasing from the positive ions and the negative positive side and the negative side, means anode and the cathode. Now if we are talking that anode, this is the anode side and this is the iron. So iron is what, like Fe. Okay, so Fe irons start releasing from this one, and if you will see the valency of iron, then it is 2. Okay, so what is the meaning of valency is that when this Fe iron will releases from this workpiece, then they will basically releases 2 electrons. Okay, so 2 electrons, if it will release, then it will become Fe plus plus or 2 plus also we can say, like on behalf of Fe plus plus you can also write Fe2 plus or plus 2. Okay, so this also you can write, but in books when you will study it is Fe plus plus written, so that's why I'm following the same code. Okay, so they will basically start releasing the Fe plus plus ions from the workpiece. Okay, now as I said that the electrolysis that we are using, the characteristics or the properties of this electrolyte is used as per that the electrons which is means the cathode side, means electrons is has to be released from the tool side, but the characteristics of the electrolyte should be, means the electrolyte should be that much enough that before start releasing the negative ions from the tool side, the electrolytes itself start releasing negative ions. Please keep in mind, this is very important. Otherwise the students think that if the positive ion is releasing from the workpiece, then definitely the negative ion should releases from the cathode side. It should be happen, but it is not happening. The reason is the characteristics that we are keeping, that we are taking for the electrolysis, that is that much enough that before start releasing the negative ions from the tool side, the electrolysis it start releasing the negative ions from itself only. Okay, so now if you will see the negative ions, then H2O. Okay, H2O will releases the negative ions, that is OH minus ions and H2 gas. Okay, so please keep in mind this one. Okay, now what will happen, how the material is removed, whatever the material that is positive ion that is removed from this one, they will react with the OH minus ion, that and they will form the sludges. Okay, so because of that the material start depleting from the workpiece area. This is the mechanism or this is the working. Okay, so please keep in mind, this is basically the reactions takes place at the anode and the cathode. And finally, so now if we are talking about the anode, then at anode what is happening, which is a positive side, Fe that start releasing, means iron is there, so that releases the electrons. So Fe plus ions, means positive ions start releasing from that. So this will be 2 minus ions. Okay, now these electrons will react with the electrolysis, because before releasing the negative ions from the tool, these electrons are reacting with the electrolysis part, so they start releasing the negative ions. Okay, so if we are talking about at the cathode, actually it is not happening at the cathode, but is positive ions is releases from the cathode side, sorry, anode side, then we have to mention that negative ion should be releasing from the cathode area, but actually it is not from the cathode but from the electrolysis. Please keep in mind this one. Okay, this is very important. uh, okay, so please just give me 1 minute. Okay guys. Okay guys, so Okay, so at the cathode side, if we look at the cathode side, then actually it is not occurring in the cathode, but in the electrolysis. Okay, so if we are talking about the electrolysis, then H2O is there. Okay, so that will basically react with this. That will react with the OH minus ions, sorry, electrons, that is 2e minus, and that will releases the negative ions, that is OH minus ions plus H2 gas. Okay, now balance can be done after means once basically important is the concept, balance तो आप कर ही सकते हैं बाद में, ठीक है, इसको 2H2O ले लीजिए, this is H2 2OH minus ions. Okay, so that will that will be 4H2O and 2O. Okay, so that will be balanced. Okay, so this is this is how you can do at the anode side and the cathode side. Now actually these ions are releasing, now these ions will react with each other, because these positive ions are there, they will react with the negative ions. So FeOH twice means Fe ions plus that will react with the OH minus ions. Okay, so they will form the FeOH twice. Okay, now when they form the FeOH twice, it doesn't mean this is nothing but the sludge. Okay, now this is OH minus ion, OH minus ions are there in the electrolysis. Okay, now these Fe plus ions are reacting with these OH minus ions, okay, and forming the FeOH twice. Okay, now it doesn't mean that when the form is sludge is formed, means here the sludge is formed in between. Now this is basically trying to sediment over the surface bottom side of this container. So what will happen, there may be a chances that they can react with this sludge, can be react with another OH minus ions. So what will happen, when this FeOH twice minus twice ions, they can be react another time with OH minus ions, and they will form the FeOH thrice. Okay, so this is also another category of sludge, means the strongness or the bonding is increasing, okay, as the OH minus is ion is reacting with that. Okay, so now if these are just based on the ions, but if you will combine these two equations, that is first one, this is Fe, and this at the anode and the cathode, then you can write overall equation will be like I'm writing out at the top. So that is Fe plus 2H2O plus 2E minus, that is Fe ions. Okay, and okay, just leave this 2e and 2e, that is plus 2OH minus ions plus H2O, or on behalf of this you can write FeOH twice plus H2 gas. Okay, so this is the gas that will be exhausted, okay, into the atmosphere. Okay, so this is like FeOH twice. Now again you can form another equation, that is that can react with this one. Okay, so because okay, so this is FeOH thrice is formed. Fine. So this is the reaction takes place when you are using the simple water. Okay. Now let's move to the salty water. So guys, is there any problem in this one? Because now onwards you will feel that you are not only studying the mechanical engineering, but the electrical engineering or the chemical engineering is also a part of your curriculum. Okay. So if you have any doubt, you can ask me at any time. Okay. So now let's move to the salty water. Okay, so now we are using the salty water as a electrolysis. So this is the container in which we have filled the salty water. Okay, now salty water is nothing but the H2O is already there. This is H2O is already there. Plus we are mixing, that is NaCl, that is salt. Okay, the salt is mixing. Now is same things, we are creating a potential difference. Now the once the potential difference is created, it will reach to the steady state conditions, and same like previous one, here the workpiece is we are making using of the iron. Okay, so and the same thing, same as per the principal part, that is anode, and this is the cathode. Okay, now anode, that is positive ions that will releases that is Fe plus plus ions that will releases, and two negative electrons, so these releases Fe plus plus ions. Okay, now same concept of the electrolysis, that before releasing the negative ions from the tool side, we are keeping the characteristics of the electrolysis that much enough, which before releasing the start negative ions from the tool, it electrolysis, it should start itself negative ions. Okay, so if we are talking about the H2O, then that will releases the OH minus ions and the H2 gas. Okay, By the way, it is of two quantity of H2O that makes, okay, because H2, otherwise you will ask me that how, sir, OH, H is there and H2 is there, so this is three hydrogens, okay, so balance is done, after that only we are releasing. And NaCl is also there, salt is also there, which is a combination of that. So Na plus ions, that is sodium ions, that Na plus, okay, and the chlorine ion, that is negative side, okay, so that releases. Now if so, they basically react with each other and they will form the sludges, okay. So now if you will see at the anode part, then the positive, that is iron, is releases Fe plus ions, okay, and two electrons, okay. And if you will see at the cathode, again the same thing, actually it is not happening at the cathode, but positive ion is releasing from the anode, so we have to write that cathode ions are also releasing from the negative side, okay, means negative ions are also releasing from the cathode side, okay. So there are two things, H2O, they will react with two electrons, and they will releases the OH minus ions plus H2, okay. Now NaCl is also there, so they also, as it will reaches to the potential difference, it also releases positive and the negative ions, okay. Now if you will think about this Fe plus plus ions, then they can react with this OH minus ions, fine. Another is this means, it depends that which has a more frequency. Now this Fe plus plus ions can be react with the Cl minus ions as well, okay. There is another possibility that this Na plus ions can be react with the OH minus ions. By the way, there is a very less chance that these Na plus ions will react with the Cl, because that is released from that, okay. So there are three possibilities. First is Fe plus ions can be react with the OH minus ions, they can form the sludges. Fe plus ions can be react with the Cl minus ions, that can form the sludges. And Na plus ion, they can react with the OH minus ion and form the sludges, okay. So now if you will see, okay, so just write it as per the ions, you can write the reactions, that is Fe plus plus ions, okay, they will okay, they will react with the 2 OH minus ions, okay, and they will form the FeOH twice, okay. Or Fe plus plus ions can be react with the 2 Cl minus ions, and they can form the FeCl2, okay. And you can also write that Na plus ions, they can react with the OH minus ions, and they can form the NaOH, okay. Now NaOH, FeOH twice, FeCl2 is nothing but the sludges only, means wastage of the material which is depleted from the workpiece area, okay. Now these are the ion based equations. If you simply combine these three equations, then the equation will become, I'm writing over there, that is Fe plus ions, sorry, Fe, that is iron, and that will react with the H2O and NaCl, which is a salty water. This is the combination H2O plus NaCl, and they will releases, basically they can form this FeOH twice, FeCl2, and NaOH, and one more, that is H2 gas, okay. So that become that exhausted into the atmosphere. So these are the sludges, okay. Now is the same thing, like FeOH twice, when it is sedimenting, when the formation is takes place, it will sediment over the container bottom side. So when it is trying to sediment, there is a negative OH negative ions are also there, so they can form FeOH thrice, sorry, this one, okay, FeOH thrice. So this can be possible, okay. So this is nothing but the sludge, or we can say the wastage material from the workpiece, okay. So these are the two reactions. First, this reactions was based on the simple water, okay, which form the FeOH twice or thrice, we can say. And when we are talking the salty water, there is a two more sludges is formed, which is FeOH twice, FeCl2, and NaOH, okay. So please keep in mind these two reactions. Please, till nothing has been asked from you that you should write for both, okay, only write for one, okay. Try to be please think of it, okay. This is just the two example that apart from this also there are number of electrolysis is available. We can apply same equations for these them as well, but I just briefly discuss, because in both the books, when you will study from one another book, both the books, then you will found that okay, in one it is simple water and another it is salty. So no need to confuse, it depends that what electrolysis we are using, okay. So let's move to the next one. So now let's come to the result part. Okay, so what is the results from these reactions? Okay, and this is very very important. Okay, I have written only the important part of these results. So first is like iron gets dissolved from the anode side and form the residues, that is Fe plus ions or FeOH minus ions, FeOH twice or FeOH FeCl2 ions. Okay, so that is that get dissolved and form the residues. Okay, hydrogen gas and hydroxyl releases at the cathode. Hydroxide is nothing but the OH minus ions. Okay, so that is FeOH twice, we can say that it is hydroxyl, iron hydroxyl. Okay, we can say like that. So that is formed. Second one. Third one, the metal from the anode is dissolved electrochemically, and the amount of dissolved that depends on two things. Means the metal which is depleted from the workpiece area, that depends on two things, and that is dissolved in electrochemically only, because that is everything is done in the EC cell. So that depends on the amount that is depleting from the workpiece area. That depends on two things. First is, means the amount which is m, I am representing with that. So that depends on two things. First is the q. Q is nothing but the amount of charge that pass through the EC cell, means the potential difference that we are creating, means what is the voltage and what is the current on the basis of that, means how much amount of the charge is passed through that. Okay, because it is taking the time to reach the steady state condition. So that depends that how much quantity or what the range of the current or the voltage we are taking. Okay, if the high power we are using, then steady state reach very early. Okay, otherwise it takes the time. Second is, this m is depending on the atomic weight and the velocity, sorry, valency ratio. So, please correct me. Atomic weight and the valency ratio. Okay. Now, so you can just combine these two things. That is, m will be directly proportional to the first is q, and m is directly proportional to the a by v ratio. Okay. So a is the atomic weight and v is the valency. So if you will combine these two equations, then m will be directly proportional to the q into a by v. Okay, so this is just, it will just multiply. Okay, now if you will release m is here, m is what, m is the amount that is dissolved or depleted from the workpiece. Q is the charge that is passed through that. A is the atomic weight, please keep in mind this is atomic weight. Okay, and v is the valency. Okay, okay. Now if you will remove this proportionality sign, then this m will be equals to q into a upon f into v. Okay, now we are taking this proportionality sign as a 1 by f. Okay, and this is, f is nothing but here, f is the Faraday's constant. F is Faraday's constant, and that will be equals to 96,500 coulombs. We will discuss number of problems on this ECM process, but for an example, if the value of capital F is given to you, then you will be considered what the value is given. But if it is not given, then please consider this one like 96,500 coulombs. Okay, so here whatever the value that we are getting of this m, that will be in gram. Please keep in mind, this is very very important. Okay, whatever the value that we are getting from here, that is in gram. Okay, now one more thing is that here we can replace this equation or replace this q, because q is what, q is the amount of charge that is passed through this EC cell. Okay, so this you can replace this q will be equals to what, how much amount is passed through that, that is will be equals to I into, okay, this is I into t, that how much amount of the current that is passed through that, uh, okay, to the timing. Okay, okay, let's leave it. We will discuss in the material removal rate tomorrow, or next in the next class. Just leave it for that. Just remember that m will be equals to, that is q into a upon f into v. Okay, so that will be whatever the value that we are getting, that is in gram. Okay, now the electrolyte, that the electrolyte that we are using, as I mentioned in the previous one, that electrolyte should be selected carefully such that it should provide necessary reactions without plating the cathode. Okay, means before releasing the negative ions from the cathode side, the electrolyte, it should start releasing the negative ions. Somebody is telling something, do you have any doubt? Guys, any one of you have any doubt?
No, sir.
Okay. Okay, so without plating the cathode, so whatever the reaction is takes place means the negative ions that releases from the work from the sorry electrolysis. Okay, when it will react the positive ions. Okay, so positive ions basically releases from the workpiece, so they are making the sludge. But it should not happen that the positive ions that is releasing from the workpiece area, they will basically react with the negative ions of the tool. So it can be happen, but the negative ions which is releasing from the tool area, before that only the electrolysis is start releasing that negative ion. So this is the very important characteristics you have to keep in mind in this one. Okay, so what are the other functions that we can use, or the characteristic that we can use for the electrolysis? Is the complete electrical circuit between the workpiece and the tool. Okay, uh, yeah, because how many things are required to make a EC cell, because it's a EC cell only. Okay, okay, EC cell, one is the tool, another is the workpiece. Okay, it should be like it should have a good conductivity of electric conductivity. Otherwise, if do not have the electric conductivity, then the material will not be removed from this one. Okay, so we have to keep in mind that as well. So to workpiece, tool, the proper wire or the supply, electric supply, power supply we can say, and the electrolysis. Okay, so that will basically complete the electric circuit between the workpiece and the tool. Okay, that carry away the heat generated during the operations, or like as the heating is takes place. So whatever the material is removed, here the material is not removing due to the heat. Okay, because the power is supplying. Now this, because of the power supply, because of the rise in temperature, the complete this because of the rise in temperature, there will be no heating. On behalf of heating, the material start removing, or the ions start releasing from the workpiece area. Okay, or from the electrolyte, so they are basically reacting. So please keep in mind that how the material is removed. The material removal rate takes place in the ECM, or electrochemical machining, due to the ion displacement. Please keep in mind. By the way, this I have to discuss in the last slide, but I forgot to keep that, because ion is moving from here and there, and because of that only the material is removed. So please keep in mind that one. Okay, so heat is, whatever the heat is generated, that is carried out along with that. Okay, the last one is, it carry away the product of reactions from the zone of machining, means the sludges that is formed, that is sedimented at the bottom side of this container. Okay, next is about the ECM tool. So that you can say that the tool that we are using, that will not that is not releasing the negative ions. So that also we have to keep in mind. Okay, so the selection of tool material should be required while designing the tool, or maintain a constant gap between the first the thing, that is constant gap between the workpiece and the tool. Okay, after that only the material start releasing. And what are the other follow characteristics, or the functions that is required for the ECM tool is, not the electrolyte but the ECM tool here. The high thermal electrical conductivity, or the thermal conductivity. Okay, good stiffness, and high corrosion resistance. Corrosion resistance is required because it is, we are dipping it inside the chemical. Okay, and we can say NaCl. NaCl yesterday we were using for the etching purpose. Okay, in the chemical machining. So there we are using this, and because of the corrosion only the material is removed. But here the due to the corrosion we are avoiding. So we have to keep thinking as per the requirement. Okay, today our requirement is like, we do not have to remove the material due to the corrosion. Okay, we have to remove the material due to the ion displacement. So that we have to keep in mind. For that the tool should have a high corrosive resistance. Okay, good stiffness, as well as high thermal conductivity, because thermal conductivity should be required for the workpiece as well. So the workpiece, the work material which is depleting from the workpiece, it after some time it will start releasing from the tool as well, because we are, how the material is removed, because the minimum gap, now minimum gap is maintained between the workpiece and the tool. So we are moving this tool toward the workpiece side. So if the material is removed from the workpiece, then definitely after some time the material will start removing from the tool side. So we have to keep in mind that thing. Okay, So what are the parameters? I think this is last slide for today, or one more question we have. Okay. So what are the parameters that we have to keep in mind? This is very, very important. Okay. The current that we are using, that is in the range of 500 ampere to 40,000 ampere. Please keep in mind this one. Okay. And the voltage is very minimum. Okay, so this is happen that what actually the surface or the heating input or the power density is required. Okay, so here basically we are keeping the current very high and the voltage is very low. Okay, the feed rate, the tool which is moving with the velocity that is in the range of 0.01050, okay, to 15 mm per minute. Working gap, that should be the minimum gap that is required, that is 0.10 to 2 mm. That this is varying because the different types of the workpiece we are operating, so this gap is varying. Okay, and the surface roughness that we are getting in the range of 0.20 to 1.5 micron. You can see this is a classical uh, surface finishing that we are getting. Okay, in the conventional machining operations, we are touching the workpiece to the tool and then we are removing the material, but we are not getting that much surface roughness. But here, without any contact, only between the workpiece and the tool, we are getting this much of the surface roughness. Okay, so this is quite satisfactorily. Okay guys, so there is a one question, objective question that is asked in gate 2001, that is in ECM the material removal rate is due to. I hope I have already discussed this question, due to the corrosion or erosion, fusion or ion displacement. Can you tell me the answer? A,
And
B, C,
Iron
D?
displacement.
Displacement.
Yes, good guys. It's a D, ion displacement. Okay. So thank you so much guys. Or like if you have any doubt, you can ask me. Actually guys, it's a completely theory session. That's why I'm not taking